Thanks, sir.
Very good afternoon to all of you. As you know, today we are going to learn on the basic of remote sensing and geographic information system from Professor Benidhar Deshmukh. Professor Deshmukh is he is in School of Science, IGNOU, and before he joined School of IGNOU, he was in that Remote Sensing Application Center, National Remote Sensing Application Center, Ahmedabad. The details I have already shared with all of you about his publication, about his expertise. So without taking so much time, and since most of our learners already knows about him through that discussion forum. So with this, I would like to invite sir for this session to give, a brief about to teach us about the basic concept of basic of the ecosystem, that's basic of this remote sensing and the geographic information system. Please, sir.
Okay. Thank you, Dr. Kuman, for providing me an opportunity to interact with the PGDSS learners. So, without much of background, I will just start here. The topic today, as you mentioned, is remote sensing and geographic information system. So, most of us are aware that just move. Slide is not. Okay. So many of us use in our mobile different maps, etc., for planning our travels, or to move from one place to another, or see locations of some places. So this is a residential complex within IGNOU campus in Delhi. This is how a map look like. Now, why I'm showing this map? See, this map is a form of GIS, Geographic Information System. That is why, although most of us use these technologies, but we may not be knowing what exactly this is. So we will try to learn the basics of these technologies. This is another image that is a snapshot of ISRO's geoportal, that is Bhuvan. So Bhuvan hosts lots of data, different kinds of data are available in that for visualization and also for downloading. So I'm not showing the other popular data portals or the portals that we often use, but I'm showing a government one. But of course, I'm showing another which is not very commonly used, that is from here maps. So this is a image that we are often familiar with, as we see in the Google Earth, etc., or Google Maps, etc. So this is image as in this image you can see there is a part of a river in a part of Gujarat, and where is you can see the bluish things are there. I am just showing moving my cursors. So this is the part where there is water in the river, and there are other parts of the river where there is a sand or other features are there. Besides that, in the southern part, in the bottom part, there are some agriculture areas and also habitations. Okay, so we are familiar with this because although this is a top view, this is the satellite view, but whenever we observe things on the ground, we observe that vegetation has green leaves, and that is how we see these images. So these images, Google Maps or Bhuvan, etc., they show images which are true color. So only thing is the difference is in the perspective. While we are on the ground, we are seeing the side view, but the satellites observe the top view. Okay, we'll come about that, about the color composite detail later. So this is the brief outline of the things, the topics that we would be discussing today. So we will start with the remote sensing. We will discuss the definition of that, the basic concept, the process, and the electromagnetic spectrum, the spectral signature, which is the basis of identifying different features on a remote sensing image, and what is an image, and what are the color composites that we will see. And then there are also the different types of remote sensing, their advantages and limitations. Then we will come to the second component, that is geographic information system. We will have a brief overview of that, and then although the title mentions remote sensing in GIS only, but the discussion is not complete unless we add another component, that is a global navigation satellite system. And all this form are part of geoinformatics that we'll see. Then what is the application potentials, where all these technologies are used, and then the kinds of data and their types that we use in this, that we'll also discuss. And the important thing is that where are we can find such data that we can use for our applications, for our work, that we'll try to see. And then geospatial data analysis tools that are there, freely available tools are there that we can use for analyzing this data. Then we'll have two slides on the covering the definition of image interpretation and the kinds of products that are that one can generate using this, and very brief overview of national agencies and the initiatives of the government of India in this field, and discussion, a small discussion on the career options in this field. Okay, so we'll start with remote sensing, the first component. So when we say remote sensing, there are two terms, as you can see, remote and sensing. So when we say remote, as you know, it is it denotes a distance. So it is a from a distance, and sensing is acquiring information. So remote sensing can be defined in short as process of acquiring information from a distance. Another definition is in little detail is acquisition of information about Earth's surface features through some instruments placed on aerial or satellite platforms. Now, the definition given by Tilson and Kiefer is it is the science and art of obtaining useful information about an object, area, or phenomena through the analysis of data which have been acquired by a device that is not in contact with the object, area, or phenomena under investigation. So this definition covers what this is, whether it is a science or art, and what is being acquired. The information is acquired about what, and then by which device, and what is whether it is in contact or not, and about what. So this is what the definition covers, all these aspects. Now, we in this definition we saw that it was defined as the science and art. Now, how come something can be both science and art? Remote sensing is a science when information from the images are extracted from the data based on some scientific facts. Then it is called science. So it is an art when information from remote sensing images are derived through some background or prior knowledge, which knowledge has been acquired through some experience. However, as you can see in this definition, it is mentioned as both science and art. Okay, so whenever the remote sensing analyst derive information from remote sensing data, they generally do it using scientific facts and also based on their experience. So the both are covered in that. Now we coming to the concept of remote sensing. This is a brief this is a picture that gives an overview of the concept. When we say remote sensing, there is a device which is placed somewhere, maybe airborne or maybe spaceborne, and it captures or it acquires information in the form of signal. The signals are coming from the objects which are on the ground, and the signals are in the form of radiation. So the radiation is the medium which is coming from the sun. So this is a case of a passive remote sensing, wherein sun is a natural source of energy, and from there the energy falls on the ground, and then it interacts with the Earth's surface and the Earth's surface features, and from there the signals are captured by the sensor, which are placed either in air or in orbit. Now this is the image that we saw initially. You can now recall. This is the example of remote sensing image acquired from satellite. This is another image that is different from the previous image, although it covers the same area, but of a different time. Now, in the previous image, it was showing different colors, and in this image, it is showing different color, entirely different color. Now, this difference is due to the band combination that we use to display, to visualize those images, those bands in our computers. We will see about that, the color composite, just little later, but let us discuss the remote sensing process first. As we saw in that the concept of remote sensing, there are several steps involved in this process, and we observe objects because there is a source of radiation that interacts with the objects, and the radiated light is captured by our eyes, that is sensors. Now eyes send signal to a brain. That brain, we can compare it to a processor, which processes the data and converts that into information. So now this is a very simplistic say example of remote sensing, wherein we can compare that the sensor that are placed in orbit to our eyes, and so this is the example wherein our eyes see something, the eyes are sensors, and the signals are recorded by our brain, and it processes and it converts that information, and that is how we know the objects we are seeing, whether it is a plant, or it is some vehicle or some building, whatever. So as soon as we see something through our eyes, we know what that object is. So this process involves several steps, as we mentioned. So the first is that there is a source of energy, as you can see in this slide. Then the energy interacts with the atmosphere. Then on the Earth's surface features, here I'm showing some trees here. And then again, after interaction with the Earth's surface features, the signal means this interacted radiation that travels to the atmosphere and is captured by the satellite. Okay, so this the satellite records the energy and is transmitted back to the Earth station, the ground station, and then the data is converted, the signal is converted in form of data in the image, and that image is distributed to the users, whoever needs it, whoever has asked for the data, or it is also made available on the portals, data portals, and then the analyst analyzes the data, and then he or she generates the output that they are interested in. Now, when we talk about medium, as you know, the electromagnetic spectrum, which ranges from, say, gamma rays to the radio waves, and generally the remote sensing utilizes the portion of visible and infrared regions for remote sensing. So, of course, different objects, different features, they have their own distinct properties, and based on that, they interact differently with the light of different wavelengths. So this slide shows some wavelength regions that are commonly used by remote sensing. In remote sensing, this is a visible spectrum, visible portion, and this is the infrared regions. and this is also the microwave which is also used for some kind of remote sensing. But the data that you see mostly in Bhuvan or Google, they are generally the result of optical visible spectrum. Now, the concept basically is how you identify different features from the images is that this, as I mentioned, that it is based on a spectral signature. What is that? Different objects have their own chemical compositions, and based on that, they interact differently with the light of different wavelengths. Now, when we see a plant, we see that the leaf is green. Now, why does it appear green? The healthy plants appear green. Otherwise, the plants which are not in good health, they might appear, their leaf might appear yellowish or reddish or dry. So, depending upon what is the constituent of the leaf, the it will interact with light different. That we'll see in a slide. But here we would just like to see what is the difference between these two images. The difference is that in this image, which is visible, it has been there are three different images acquired in the blue, green, and red wavelength regions, and that is how we see. As we can see in the visual, our eyes also has limitations. We cannot see things beyond the visible range. So this image has been taken on the visible range. That is how it appears, similar to what we see through our eyes. But this image on the lower right, uh, it also has a band which has been taken in the infrared regions. So as we know that there are three primary colors: red, green, and blue. So when we have images acquired in red, green, and blue wavelength, and when they are exposed to the infrared regions, the
Sir, there is no voice. Audio, please. Audio. Sir, audio. अच्छा नेटवर्क प्रॉब्लम दिख रहा है. अच्छा, Yes, we are able to see. आप full mode में कर दीजिएगा सर. Audio open कर दीजिएगा सर. Audio is not open.
Okay.
Yeah.
Okay. Sorry for the inconvenience. There was a network issue with the system. Okay, so we were here at this slide. We're talking about the digital image. Now, this is an image which has been acquired in some band. This is basically in the near infrared wavelength region. And this is how an image typically looks like. Whatever color you see, whether it is a bright or dark grayscale, it is due to the digital number that it reflects. Okay, that it has. So depending upon the digital number, the brightness will be dependent. If it is having higher values, it will be appearing brighter. If it is having showing the lower values, those pixels will be appearing darker. Okay, so now an image typically has a distinct number of pixels, rows, and a spatial reference. Now, coming to the color composite, as I was mentioning about the three primary colors, red, green, and blue. So this is fixed. This is fixed in the monitor, and we may have n number of bands taken from taken in different wavelength regions, and we can assign these different bands to whichever plane that we want to visualize in. So that is how, if you see individual bands, they will appear in grayscale. But to see those bands in color, we can assign them in some different color planes of the computer monitor. And suppose this is the band which was taken in the red wavelength. When we put in the red plane, then it appears reddish, and then similarly, image that was acquired in the blue wavelength, it appears bluish. So when we combine these three, and then this is how it will look like. So it will have a color composite. Now, this is a typical thing where there is no change. Like the red plane has the band, the data that was acquired in the red wavelength regions. Similarly, the green and blue in the respective wavelength regions. But suppose a data has been acquired in the wavelength region beyond the visible spectrum, then also we can visualize those data within this color planes. So simply we may remove any of this. Suppose I don't have a data of a blue wavelength region, then in that case I will assign data which was acquired in green wavelength into the blue plane, and the data which was acquired in the red wavelength into the green plane, and the near infrared regions data that I will give in red, assign red plane. So that is how you saw in that image that the vegetation was appearing uh, uh, green in this true color image. Otherwise, when I have a false color image wherein I have a near infrared image that I have assigned in the red plane, then wherever there is a vegetation, it will appear red. Why? Because within the visible spectrum, the vegetation has higher reflection in the green wavelength region. That is why it appears green to our eyes. Otherwise, if you see that entire spectra, we know that much more than the green wavelength region, there is a very high reflection of vegetation in the near infrared regions, and that near infrared data uh, we have put in the red plane. That is why the vegetation areas appear as red color in this color composite, and this is not true. That is why we call as false color composite. Now, let us have a brief overview of the interaction of electromagnetic radiation. This is, as I mentioned, I have shown slide twice, but in different context. As I mentioned that the sun is the natural source of energy, and from there radiation travels to the atmosphere and reaches the Earth's surface. Here the example is for the water surface, and depending upon the size of the atmospheric particles, there will be scattering in the atmosphere of the light, and depending upon the characteristics of the earth objects, like in this case water, it will reflect certain portion of the light and it will absorb certain portion of the light. Okay. So we were talking about the spectral signature, and this clearly tells us that why we were seeing red color for the vegetation. As I mentioned, within the visible spectrum, this is the visible portion. Within the visible portion, the reflection from vegetation is much higher in the blue wavelength region. But beyond that, the reflection is much high in the near infrared regions in this portion, and also in mid infrared regions. So that is why when we don't have blue data, and we are assigning the near infrared data in as red plane in the red plane, then that is why the vegetation areas are appearing in red color. Now, this is a typical spectral signature, or say a spectral profile of vegetation. Depending upon the kind of plant, that could be broadleaf or not so broadleaf, or conical, say in the hilly areas, alpine trees, there will be, the plants will be different. So depending upon the leaf structure and thickness, the content of the chlorophyll and the moisture content will be different, and depending upon that, one can uh, uh, see the difference in the spectral signatures of different kinds of plant communities. However, just for your information, uh, the, based on the moisture content, uh, this is generally used for identification of different kinds of plant species. Now, this is the spectral signature of soil, wherein we can say this is a dry soil, which general, I'm not showing any different kinds of soil, but generally it has a higher reflection when you move towards the higher wavelength regions. This is for water. Water has a higher reflection in the blue and the green regions, and beyond that, there is much of absorption. And when you come towards near infrared, there is a total absorption of the light in the water. Now, coming to the different types of remote sensing, we can categorize remote sensing into different types based on the platform. It could be ground-based or airborne or space-borne, and based on the source of energy, it could be called as a passive remote sensing or active remote sensing when there is an artificial source of light energy source in the satellite. And based on the imaging media, it could be called as photographic imaging or a digital imaging. And then based on the region of the electromagnetic spectrum that has been used for remote sensing, it could be called as optical or photographic or thermal or microwave. And depending upon the number of bands and the contiguity of the bands, it could be panchromatic or multispectral or hyperspectral. That is also known as narrow band imaging. Now, the advantage of remote sensing is that it gives us a synoptic view, and we can acquire data of regions which are at times inaccessible to us. And it is also a cost-effective means of data collection in the long run. And we can observe or visualize data even beyond the visible range. And it is also an unobtrusive means of data collection, which doesn't change the characteristics of the object that we are observing. And we can also have historical data sets which are useful for understanding the characteristics in object within a given point of time in past. However, there are certain limitations of remote sensing, which some of these are listed here. One of them is the non-availability of appropriate data, particularly in the tropical regions due to cloud cover, etc. And sometime the kind of remote sensing like laser, etc. Uh, they might affect to some extent the phenomena that is being investigated. And at times also, the some of the remote sensing systems can become uncalibrated, so that might induce some errors in the data that is being collected by those sensors. Now, coming to the second component, that is a geographic information system. It is defined as a computer-based information system which is used to capture, manage, update, analyze, display, and output spatial data and information to be used in a decision-making context. Now, this is important here. The GIS, when we say it is always used in a decision-making context. So, what does it do? It integrates hardware, software, and data for capturing, managing, analyzing, and displaying all forms of geographically referenced information. And it allows us to visualize, understand, question, create different scenarios, and interpret data in ways that reveal some relationship or patterns of and trends of which is available in the data. So this is a example wherein different layers of different themes have been generated, and this is how you can analyze a number of data layers in GIS. And there are 5 components of GIS: data, software, people, method, and the hardware. T is missing here, hardware. Now, coming to the third component that we also often use when we use Google Maps, etc., we see that besides seeing the map, we also know that certain like we can track vehicles, we can track ourselves where we are moving. So that is possible based on this global navigation satellite system. However, the most common example is the global positioning system or GPS of American of USA. So this is a constellation of Earth orbiting satellites which provides autonomous geospatial positioning with global coverage in real time. So this is in short about GNSS. So basically, the GPS, as I mentioned, is the popular one. It's a constellation of satellites which orbit the Earth at an altitude of about 20,000 kilometers. And these satellites broadcast signals which are used to derive location information and are useful for navigation. So there are GPS handsets which are available, but also you can in our mobile also there are softwares available which gets location information. However, the most common use are for vehicle tracking and even for us for moving from one place to another. So when we say geoinformatics, basically it is a combination of all this component that we discussed and some more. So like this remote sensing, GIS, and the GNSS are the common components. Besides, there are many other components like photogrammetry and cartography. So geoinformatics is basically a synergy of various disciplines like remote sensing, GIS, GNSS, cartography, geodesy, photogrammetry, etc. And when we say geo, as you know, it is Earth. It refers to Earth. And when we say informatics, it is related to the representation, processing, and communication of information. So it is defined as the science of the gathering, processing, and dissemination of information, which is spatially defined within the Earth system. The advantage is that it is relevant wherever there is a spatial data, meaning that the data which can be referenced to some part of Earth or space. And it is a means of rapid and periodic data collection, particularly when we talk about remote sensing and the GNSS. And we can use GIS to create and visualize different scenarios, and it is useful for planning and management. So basically, if you of the 3 components that we discussed, remote sensing and the GNSS are the data acquisition technology, whereas the GIS is the data processing technology. Now there are various applications of these technologies. The most common that we see are the weather forecast that we see in Delhi in the morning or in the evening. The forecast that we see about the weather that is generally based on the inputs that are provided by satellites, basically the geospatial satellites. Then beyond that, there are many other areas like vehicle tracking, or in the coastal monitoring, or in the ocean state monitoring, or for even natural hazards, natural resources mapping and management, or in different applications like environment or geology, geomorphology. In those areas, it is commonly used. This is the list of some of the areas where it is used for weather, agriculture, environment, natural hazards, geology, geomorphology, coastal, even for biodiversity. And there are many other applications wherein this technology are used. The potential of this technology is that it has grown as a major tool, and the applications are mainly oriented to the real world problems of management of natural and the man-made environment. And due to the potential of these technologies, the use of this has increased multifold in the local and national governments also. And the government of India has included this as a important component in the many of the its national programs since years. That we can see. We will see. We will list some of the programs at the end of this presentation. Now, we were talking about the data. So before we talk about different types of data that is generated or that is used in the geoinformatics, we will just have an overview of what is the data. The data contains information which is represented in the forms of digit, letter, or symbol. So these are used to describe status, behavior, and the outcome of the geographical objects. So based on data only, our understanding, explanation, and the inferences about an object or phenomena are based. Now, when we say geospatial data, it refers to any data that is related to any features and phenomena of the Earth and has location as one of its attributes. Now, when we say spatial, it refers to anything. But when we say geo, it refers to data of the Earth. It represents real-world features like roads, land use features, land cover features, elevation, vegetation, water, railways, etc. Now, these features can be divided into two different kinds of abstractions, like discrete features, like in a house, and also as a continuous field, like rainfall amount or elevation. So these are the two kinds of abstractions which are represented as vector and raster data respectively. We'll see how it appears. This is an example of spatial data. I'm talking here about the vector data. You can see we have seen in the previous one of the slides earlier, different layers were visualized while we were discussing about the GIS or different things. So here also there are three different layers that are generated in the GIS in the vector format. This is a vector format. Now each of in this map, these are different categories. Now each of these different categories or the values represent certain kinds of classes, and it also stores not only this information that we can see in the map, but also in the back it has uh, information about that particular feature, like whether it is what kind of feature it is, and what class is, and many other features that parameters that we can include, area, etc. So these are the two basic types of data that we use in geoinformatics, that are vector data that we saw in the previous slide, wherein the data the features are represented either as point or line or as area features. The same thing that we can visualize in the raster format, which is represented in the form of grid, and instead of the points here, the point picture will appear in the raster data in the form of pixels. So this is how these two kinds of abstractions appear in two different kinds of data. Now we saw that the data are of two types, raster and vector, and again we can further classify the data into primary and secondary depending upon how they have been generated. So the example of primary data is the digital satellite images or the digital aerial photographs, and the secondary data example are the scanned aerial photographs and images, scanned film, or the paper maps, or the products that are being generated from the primary data are the example of the secondary data. Similarly, vector data also can be categorized into primary and secondary, and the data derived from GPS or from the ground survey are they fall under the primary type, and the data that have been converted from raster data or they digitized from different sources are they fall under the secondary vector data type. Now, since we are discussing about the data types, we will discuss about the sources of data that you are aware where you can find those data. I'll just list out some web links from where you can download those data, and these data are available freely. So first we will discuss about the raster data, then we will discuss about the vector data. So raster data can be obtained in a number of ways. Generally, it is by the means of aerial photographs and satellite remote sensing, and the different types of data are raster data are the satellite remote sensing, the spatial images, the data products, or the derived data, including the digital elevation model. However, note that most of this data, although they are available in certain data portals for visualization, also for downloading, and sometimes there are some portals wherein you can not only visualize but also process the data in the same portals and or the platform, and also then you can generate the output and then download the output instead of downloading the entire data sets. So these are some of the links or data portals from where you can download a variety of raster data. So this is the most common, the USGS Earth Explorer .usgs.gov. Then Globis website is there. Then the Natural Earth. However, this is more commonly known for vector data, but still it has a limited raster data availability. Then the Alaska Satellite Facility also is available. It provides a variety of data. Then Giovanni and then Sentinel's Open Access Hub. Like that, there are many data portals from where one can download data of their interest of different areas free of cost. However, one needs to register in the data portals, and they might ask you what is the purpose of the data that you want to download, that how where you want to utilize that. So these are some, and then the NASA Worldview and NOAA Class and V2 Vision. These are some other links at the data portals where we can from where we can download data. So this is an example of the landscape science, the GSFC portal, and there are links to a variety of sources for downloading landscape data. So this is an American satellite. So these are some links from where we can download data, and there are also modest data available at these different websites. Not only the original data, but also different kinds of products relevant to the land, cryosphere, and also the uh, sea. That could be ocean color and the sea surface temperature products. Those are available on these data portals. This is another portal that hosts a variety of data. I'm just giving a snapshot of the main page of that. And this is another portal of NEO, NASA Earth Observation. In short, it is called NEO. So this is by that name. Again, it is of GSFC. So they are providing data that is vegetation index, NDVI, and this is a 1 month average data that they're hosting. So one can use this data to understand the pattern of vegetation in different parts of the Earth. Now, this was mostly we were discussing about the international sources. Now, if we talk about the data sources from our own Indian sources, so mostly, as I mentioned in earlier, the Bhuvan, which is the ISRO's geoportal, a variety of data are available. Not only the primary data, but also the data products are available in that. And then of the Geological Survey of India, they have a portal dedicated for that, that is known as Bhukosh. And then the Survey of India, that they call it Nakshe. So there are also a variety of data products are available. Now coming to the another product, that is the digital elevation model, that is most commonly used data sets besides the remote sensing data. So this is the simplest form of digital representation of the topography or the land surface elevation, and it is used to determine terrain attributes like elevation, slope, and aspect at some location. So one can download the Cartoset digital elevation model from the Bhuvan portal freely. This is one snapshot which covers different areas in different uh, grids. So besides the Bhuvan, there are many data portals from where one can download a variety of digital elevation models. Some of them are like G-Topo 30, then this is DEM Explorer, and then USGS, they have again a variety of digital elevation model. But however, the commonly used DEMs are the SRTM DEM and the Aster DEM. Both of these two are the near global digital elevation model. This is another slide wherein you can find a variety of digital elevation model. Now coming to the vector data, these are some links from where you can download vector data of different regions. So this is the GADM maps and data, which is available here, and also at Natural Earth. As I mentioned earlier, that this is most commonly known for vector data. You can download variety of data, not only physical but also the cultural features vector data that you can download. Then besides that, the ArcGIS Hub also hosts some kind of data. Then the Diva GIS and the OpenStreetMap and the NASA's Socioeconomic Data and Application Center, SIDAC, they also host a variety of vector data. Then besides this, there is also available. It is also available on the integrated population and environmental data is available at data.ipums.org. Then FAO data is available. Then also global maps. So these are some sources where you can download, from where you can download a variety of vector data sets. Now coming to the data analysis tools. Now once you have data, you also uh, should have a software or tool wherein you can analyze, visualize, and process the data that you want to analyze. So there are variety of commercial off the shelf software available, and also there are free and open source software available. So however, for educational purpose, it is better recommended to use some of these free and open source software because you don't have to pay any money for that, and there are also, it is comparable to the costs. So now once you have data and also software and you can visualize those data, now the next thing is that you should be able to derive information from this data. So there are certain things that could be derived from remote sensing data, and as per Jensen, this information could be location, elevation, characteristics of different features like vegetation, soil, water, etc., even the temperature. And however, this information are not explicitly available. So one needs to extract this information from images, and this is the job of the remote sensing GIS analyst. So this can be used for mapping and monitoring the features and to suggest images if there is anything that is required to be done. So the image interpretation is done in two ways. One is called visual interpretation. Uh, it is one of the most powerful ways to retrieve information from images. And depending on the quality of image and the human expertise in image interpretation, Many of the attributes are readily identified by human eyes, and this is done by using the elements of image interpretation like tone, texture, size, shape, site, association, pattern, etc. Now, coming to the digital image interpretation, we know that uh, there could be some limitations when we go for visual image interpretation, particularly when we are analyzing data sets which covers a very large area. So in that case, and also at times we may need to highlight certain features. So in that case, we may need to go for digital image processing. So this encompasses processes wherein the inputs and outputs are images, and it extracts attributes from images, including the recognition of individual objects. However, for most of the operational purposes, uh, like preparation of land use land cover map, we generally use uh, visual image interpretation technique, provided the area of study is not very large. So once we carry out the interpretation, the outputs are they could be generated in different forms. So the geoinformatics products are generally categorized into two types. One is cartographic, and second is non-cartographic product. So the hard and the soft copy maps are the example of the cartographic products, whereas the digital elevation model or the information system or the table, etc., they are example of the non-cartographic geoinformatics products. Now, these technologies are used in different initiatives of the government, and there are different agencies that utilize the data, like Indian Space Research Organization, which is the prime agency that is responsible for developing this technology, placing the satellites in the orbit, and getting the data. And then the DRDO also is agency that uses extensively the such kind of data. Then the Department of Science Technology, the Center for Development of Advanced Computing, the Geological Survey of India, the NIC, and the NBSSWP, and the NCR Planning Board, and then Town and Country Planning Organization. So these are some of the organizations that utilizes extensively this geoinformatics technology and the data. And these are some of the common popular projects of the government of India, wherein these data sets have been utilized extensively. That is Village Resource Center, then the National Natural Resource Management System, and the Natural Resource Census, and the Pradhan Mantri Gram Sadak Yojana, the Rajiv Gandhi National Drinking Water Mission, and the crop acreage and yield forecasting projects, and National Spatial Data Infrastructure, the Potential Fishing Zone Map, and the Biodiversity Information System. These are some of the only few of the initiatives of the government wherein this technology has been used, that provided major input for this program. And if we come to the specific career options in this technology, as per the MHRD report, which came in 2013, which is available in the net, you can search and find out. There are three kinds of people who are required. They call it geospatial skill workforce, then the technical geospatial professionals, and at the top of the pyramid are the geospatial experts. So this is how the three kinds of the manpower required in this field. However, uh, there are a variety of disciplines, various disciplines wherein this is used as an important input for the research in those fields. So this is what we saw in this session. We discussed about the remote sensing, the basic concepts of that, and then we discussed about the geographic information system, and we also got introduced to the GNSS. Then we saw how this combined to form the geoinformatics, and the application potential of these technologies, the types of data, what is data that we discussed, And we also discussed about the different sources of the raster and vector data, and the data analysis tools and interpretation, the types of products that could be generated, and we also got a brief overview of the national agencies and the initiatives and the career options available in this field. So these are the references that I have used to prepare the slides, and majority of them are, you can see, the IGNOU self-learning materials from the PG certificate in the informatics program, and also PG certificate in the climate change program. So there are which are the slides I have used for preparation of this slide. So thank you for this, and if there is any questions, I will be available now, or if you have any question in future, you can write to me on this email ID.
Thank you, sir. Sir, please, close the sharing option.